Okay, in this video we're going to talk about graphical methods for summarizing data, and I'm going to really emphasize only one method, which is the frequency or relative frequency histogram. So I want to illustrate that by an example. So we're going to start with a weight loss data, say, and these are weight loss people lose based on some diet program per month. So you can see here you have 20.5 pounds, here you have 23.5 pounds, here you have 5.4 pounds. So let's look at this data a little bit further. What's the lowest value in this data? And if you look carefully, you'll find out the least amount of loss was 5.4. The highest loss was 28.6. and how many data points or measurements we have, which we call this is a sample, we call that a sample size. So if we count, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 25 measurements, and you can see our objective is we want to provide a useful summary of the available information, and the summary we are looking for is one that we can use later for further analysis, not just for displaying the values. So here is how we do that. First, we take the lowest measurement and we go a little bit below that, so we get the 5.0. that's how we got that. And the highest measurement was 28.6, so we go to 29. We call that the range of possible values, and we can divide that into 6 classes. You can see here, we'll talk later about why 6. And we're going to divide, so we're going to divide now. Let's go from 5 to 9. This would be our first class, and 9 to 13, 13 to 17, and so on. So these would be our classes, and you notice here there's a minus sign. That means you go up to 9 but not including 9. Sometimes people write 5 to 8.9 or less than 9. I prefer this notation. It's a matter of preference. So we have the range of possible values from 5 to 29 all included. We have 6 classes, and now we do a tally basically. So we go to the data here and we see our first measurement, 20.5, falls in this class. So we make the tally here and we go over all of this, create the tally for this data. And once you finish that, and you should do this, maybe you should pause and do this, you will find out what we have here, these class frequencies. See? And you'll find that there are 3 measurements from the data fall in this class between 5 and 9. 5 fall between 9 and 13, and so on. So please pause, make sure you get those numbers before you proceed. And of course we have a total of 25 measurements. That's the sum of these, we call them frequencies. So this is just a notation for frequencies. F stands for frequencies. The second thing we're going to do is this. We're going to take each one of these measurements and divide by 25. So it becomes a fraction. So that's the fraction of measurements falls in each one of these classes. And we call these relative frequencies. And since the frequency is f, and we're going to use n for the sample size, so that's f divided by n. And so the first one would be 3 over 25, and in here that's in decimal point, so that's fraction, that's 0.12. Second one is 5 over 25, and that's 0.2, or 20% of the data falls in this interval. So this gives us our frequency and relative frequencies, but we can get other measures, but that's for later. Now how did we do this? And so now what I'm going to explain how we got those 6 classes and what we're going to do with this later. And basically, if you look at this, you find out that the most weight loss happens between 13 and 17. Very close to it were 9 to 13 and 17 to 21. So the first thing, when you have a data set or a sample like this one here, the first thing you want to determine is the lowest point, the highest point, and then how many classes I want to divide my data. So if we call that K, then I want to use the maximum for the largest measurement, the minimum for the smallest measurement. I want to use N for the sample size and W for the class weight. And there are 2 ways to determine the number of classes. One is just to use a rule of thumb. Usually you pick the classes between 5 and 20, most of the time 7 to 13, and that, of course, if you have a small sample size, you go on the lower end of this. If you have a large sample size, you go on the upper end. Our sample size is pretty small, 25, so that's why we picked 6. Another one is to use a formula which gives you an idea of what the number of classes should be, and this formula is just K is how many classes you have. You take basically the sample size, and you see how you read formulas from inside out. So you take the sample size is 25, you take the log to base 10 of that, and multiply that by 3.3 and add 1 to it. And in this case, that would be like 5 point. You're gonna round, because if this is not an integer, you want to make sure it's an integer. So that gives us 6 classes. Now we determine the class width by using this formula, the max minus the min over how many classes we decided on from here, and that gives us the width of the class. So let's apply that to our data. The width should be 28.6, which is our largest measurement, minus 5.4, which is our lowest measurement, divided by 6. That gives us 3.87, but we used 4. Basically, in this case, you round a little bit to make sure you get nice class width. It gives you much better data, much better visual, because that's the whole idea of this frequency distribution, is to get a good visual of what's going on. So how do we graph histograms now? So now suppose, what's the purpose of this data? So we graph this data. Now we have these frequencies, which is very informative, but sometimes you want to compare 2 data programs, say, or data sets, and this one has 25 measurements, but the other one has 200. Then obviously your frequencies are going to be higher. So how do you compare 7 in this interval with 15 or whatever in the next data set, in the second? So that makes it harder. A way to do that is to look at relative frequencies, because that's the percentage of measurements in each class. If I have another data set, it makes it easier to compare them, because if the second frequency is higher but the relative frequency, it has less percentage in that interval, I know that fewer people based on a same sample would have lost the same amount of weight. Okay, so now how do we graph? So now we have those numbers. How do we graph them? And this is how we graph these ones. I want to show you that. This is just a summary of what we have done. So if you want to graph those, I want to show you that on my camera here. See if I can get that. Let me. Okay, here is how we graph the data. So we draw this line, vertical line, a horizontal line, and then we have the points 5, 9. It's hard to see that on the video. 13, 17, 21, 25, and 29. And here we want to label the vertical axis. That's 0.1, 0.2 up to 1. We know our highest percentage was 0.28, so we're not going to go beyond that value here. And so we graphed as our first class, it goes up to 0.12, our second class, our third class, fourth class, fifth class, and the sixth class. And then we draw, because this graph is based on the sample. So remember, what we want is a graph for the population. If we had much more data, our graph would be much smoother. So we're going to smooth that out. And that's what we do here. Just go over the midpoints and then make it a smooth curve. And if you look at this one, it looks like a bell shape. But that's not always the case. So the possible shapes, once you graph your data, would be something like this. One possible shape is the bell shape. Another possible shape is this, when you have a data where your first class is very high, then the classes go down, and you have a shape that goes downward. It's called the exponential frequency distribution, or negative exponential frequency distribution. Other possible shapes, let's see if I can get those here. This is another shape here. It's called the uniform shape. Basically, all classes are about the same height. And also other possible shapes, if you have categorical or discrete data, like say you're counting how many patients go to the emergency room per day, and you find out some days it's 0, some days it's 1, 2, 3, 4, or you never notice more than 5, and you see small percentage with 0, then it goes up higher, 4 and 5, and notice here, because it's discrete, those values are just all the relative frequency sits at one point at 0, 1, 2, 3, 4, and 5. Some books put around them some shapes like that, but that doesn't matter, because the whole frequency is at one point. It's not spread around. And so but where do we go from here? Is to remember a few things, that the normal shape is the most popular, the most useful, and the easiest to handle. So that's going to occur because it occurs really naturally in many applications, and it's easy for analysis. Remember, this is the most useful graphical method. It's not the only one. In your textbook you will see a lot of other graphical methods on statistical tables, bar charts, line charts, pie charts, and sometimes how to cheat with charts. So you can look at your textbook for those ones. But this relative frequency histogram is going to lend itself later to probability distributions, and we're going to see that very, very useful. The next video will be on how do we summarize data using numerical methods. So in this video we summarize data graphically. Then we're going to look at how to summarize data numerically by looking at two numbers, the number of central tendency and the number of variability. And so that's for the next video. Thank you.